Alright, so welcome to this video here. We're going to do a one sample t-test. We're going to use our test of means data file, and we're going to focus on the weight loss tab. So here we have a sample of lost weight from a series of study participants, and we're going to form and test some hypotheses based upon this. So if we get a sense for how many observations we have, right? Let's look at the range, the min, the max, get a sense for the average of those weight loss, as well as the variance in that measured by our standard deviation. All right, so here we have the count. All right, so we have 40 observations. Using our min function, we can get the min. The max function, get the max, the average, all right, and then lastly the standard deviation. Alright, so here we see that our 40 study participants had an average weight loss of 5.7 pounds. Standard deviation of that was 3.6, so quite a bit of uncertainty around that average. The range was minus 2.7, so some people actually gained weight, and some people lost a lot of weight at 13.2 pounds. So now we're going to form and test some hypotheses, right? Our base hypotheses here, age 0, might be that we had no weight loss, right? So in this case, mu of our population under this type of study would be 0, right? And then our alternative would be weight loss, such that mu is greater than 0, right? So here we're going to do a one-tail t-test. It's the right tail because we're looking at mu greater than 0, right? And so our test statistic for this is going to be our sample mean minus our null divided by our sample standard error, right? Our standard error is a function of the standard deviation of our sample divided by the square root of our sample size. Right, so here the error of our mean, right, our sampling mean here in this case is 0.566. All right, so our test statistic then is going to equal our sample mean minus our null, in this case, which was 0, divided by our standard error. All right. Right, so again, our test statistic was our sample mean minus our null divided by our standard error. And all we have left to do is determine the p-value of that guy. Right, so the p-value we're going to use doing the t.dist function. We're going to do the right tail of a single tail t-test. Our test statistic here, 10.1. And our degrees of freedom is our sample size minus 1. Right, and so we see here our p-value is very, very small. We would reject our null at the 0.05 level, right? So we would reject null at our predefined 0.05 level, as our p-value is considerably smaller than that. And so that provides support for our alternative hypothesis that the population under this diet would have positive weight loss.